Now after the boundary operating conditions are done, we will just go back to reference value and reselect fresh air from, compute from fresh air inlet. That is done. Now in the reference zone, if you want, you can just select this, the part name or the domain name. In the methods, I will be dealing with simple pressure velocity coupling. I have already explained the coupled and simple in my other course. Now coming to pressure, there are different options available for us for the special discretization or the interpolation of pressure. Okay, the interpolation schemes, what we can call. Now for problems that involve body forces, large body forces, the body force weighted can be selected. Okay, otherwise we can also go with presto, that is pressure staggering option. Now I can just select the second order if I really want to go with second order, and I'll just turn on the high order term relaxation. I'll just leave the controls as it is by default, and generally this kind of flows what we have, okay, the kind of flows of multi-species which are having low velocity values at inlets, right? So these kind of flows represent a kind of transient behavior. Okay, so the residuals what you will be getting in the flow will be often oscillating, right? And in that case you cannot totally rely on the residuals for concluding the convergence. Clear? So in this cases we have to monitor certain quantity in the domain which will help us to justify the convergence, right? So in some cases, because of complex shapes, the continuity equation may not reach below the convergence criteria. So that doesn't mean that, that always doesn't mean that, you know, your case is incorrect. You need to modify, you need to monitor certain values or certain variables in the domain and see whether those variables have reached a constant value or near to constant value or are oscillating uniformly, right? So that will indicate that we are closer to convergence. For this purpose, I will be creating a report definition. I will be creating a monitor of velocity. So I will be just going to area weighted average, that is over here, and from here I will be writing this as velocity monitor, and I will be monitoring the velocity on a plane which I have created when I've paused the video. Okay, so that is number plane 7. But after creating the plane, I thought, you know, I must show you the procedure for that as well. So I'll just recreate another plane otherwise. So I'll just go to new surface and click on plane, and this will be named as any random thing you can just name so that you can distinguish between the plane and the other boundaries what you have. Okay, and I want the plane to be in the XZ. You can see there is a kind of arrow being created over here. Okay, that is representing a plane. Actually, I don't really appreciate the graphics of this thing. I'm not sure whether the graphic problem is in my computer or is it default with this version of ANSYS. And we can just create it. Okay, and this is almost in the center of the domain, you can see, right? So let it be at this position, that is plane number 11. Okay, now what I will be monitoring is I will be monitoring the velocity value on this particular plane, that is plane number 11 or 11. And we can just press OK over here, and we have the name of velocity monitor. I think I've written some wrong spelling, but you can just neglect that thing. That is not significant thing. And after that you can also come to initialization, and we will just initialize from by using the standard initialization techniques, and we will compute from inlet. I'll just click on initialize and press OK. It will take a while to initialize, and after that I basically have to go to calculation activities. In the calculation activities I need to enter a random value, and that value will correspond to the saving of this ANSYS file after specific iterations. For example, if I want to save after every 150 iterations, then I just need to enter 150 over there, and after 150 iterations a backup file will be created in the save location of this project. So this is quite helpful if we are having any problems with our computer, the laptop, any disconnection because of low battery, or sudden crashing of Fluent because of some reasons. So in all these cases, you may have a backup file. You can just retrieve it. Okay, so we will be doing that thing, but I really wonder what is the reason for this to hang up. Yeah, it is done. So I'll just go to calculate activities. I'll enter 150 over here, and the edit, I'll just, yeah, by default it is selected for me. I don't know why. So I'll just select retain only the most recent files, and I'll just type 2 over here, press OK. So the last 2 files will be saved here, and after that I can just come to calculations, and I'll enter 1500, and I'll just begin the iterations. And I'm really sure the convergence may take a lot of time, so you just have to leave your system and walk off, have some cup of coffee or take some rest, and just monitor whether the things are happening appropriately or no. And this is the first time even I'm doing this case with you, so I'm not really sure what will be the outcome of this result. And let us just catch up in the next video. If I'm having any errors, which I will be given with the software, if we are facing any errors, in that case I'll just make a video for that error as well. We will just try to see what is the error, and we'll just try to solve it. If things are happening smoothly and if we are able to converge, then I will be discussing the results part in the next section. Okay, so I'm not really sure what is going to happen, only the outcome will reveal the results. So let us just wait and watch, but you can just move on to the next video in your case, but in my case I need to wait few moments, right? So let us just catch up in the next video.